Okay everyone, today's topic is Introduction to Operational Amplifiers. Before we start the operational amplifiers, let me tell you about a basic differential amplifier which is shown here. The differential amplifier is nothing but a normal amplifier, but instead of taking one voltage as the input, it takes two different voltages as the input as shown here. And the output which you get V0 will be proportional to the difference between the two voltages. Therefore, the name is a differential amplifier. Okay. Now, similarly, the proportionality constant is some constant A, which is the gain of the amplifier, and you get this output. Now, coming to operational amplifier, this is a basic operational amplifier diagram where you have two input voltages, V1 and V2, and the two reference voltages. The need for the two reference voltages I will explain shortly, and the output V0 as here will be proportional to the difference between V1 and V2. Okay. Now the name operational amplifier comes from the fact that it can perform several operations like addition, subtraction, differentiation, integration, averaging, etc, etc, etc. Okay. Now let me tell you the need for two reference voltages. Now in our normal amplifier, which is a NPN amplifier, NPN transistor I mean, you use a positive voltage as the input and we use plus VCC. Similarly, take a other case, because this our amplifier here is taking one negative and one positive voltage. Here also let us take another negative voltage. So for this negative voltage, for a similar operation as this, we will be needing a PNP transistor with a minus VCC for biasing. So now this combined circuit along with some process that you are doing after this will be the total amplifier which we are having here. Okay. Now this can be better understood if you look at the block diagram here. The block diagram consists of four parts and I'll explain those four parts now. The first part is a input stage, also called a bounded input bounded output differential amplifier, which is nothing but a differential amplifier which I explained above, but having two outputs. Okay. So that is why it's called a bounded output. We'll be seeing that in this stage there is only one output and that will be an unbounded output. Okay. So here this stage should have the following characteristics: a high input impedance, this CMRR and offset I will explain to you when we discuss characteristics of the op-amp. For now, just remember that it has a high CMRR, high gain and low offset. Okay, the meanings I'll explain to you in the next lecture. High gain is required because the input stage essentially provides most of the gain in the operational amplifier, so it should be a high gain amplifier. And coming to the next stage, as I said above, it is a bounded input, unbounded output. Here the unbounded output means only one output here. Okay, so this is an unbounded output. Now here these are the characteristics. Similarly, this is also a high gain amplifier, and this essentially consists of many stages of cascaded amplifiers. The reason for this is because one amplifier is not enough to provide the gain which is needed in an operational amplifier. Okay, so to provide a large gain, many number of amplifiers are used here with direct coupling. Remember, this point is very important when we discuss the next stage. Okay, so this is a cascade of many stages. Now the third stage is a level shifting stage. Now in the above stage we discussed that there is no coupling. What happens when you have a coupling? When you have a coupling, all the DC signal that comes from one stage to other is blocked by the coupling capacitor CC. Now because we don't have any coupling, the DC signal builds up at each stage. At the first stage it is like this, second stage it keeps building up higher and higher value. So what happens is our Q point, the operation of the transistor which is needed, the Q point changes, but we don't want this Q point to change. We want the transistor to operate in stable region. So for this purpose we have to bring the DC level to 0, back to 0, and to do this we'll use a level shifting stage. So a level shifting stage is nothing but a CC amplifier, CC stage with a high value of input impedance. This high value of impedance is required to avoid loading effect on the previous stages. Okay, next the output stage, final stage. The final stage of this amplifier is a power amplifier. The final stage of this amplifier is a power amplifier, where generally a push-pull class B, you have studied this in your second year. Push-pull complementary amplifier is used, class B amplifier, because the reason is because the large output is required here and low output resistance. Why a low output resistance is because there is a loudspeaker at the output of any system like this, and the loudspeaker will have a low input impedance, so the matching should occur between these two. Therefore we need a low output, and high current sourcing and sinking capacity is required to deliver current to many different outputs. This is about the operational amplifier. Thank you.